for this video, our topic is all about SinTanCos hexagon. So, this is the figure. So, we have sine, cos, cot, cosine, secant, and tangent. So, for quotient identities, all of the quotient identities can be found by either going clockwise or counterclockwise around the hexagon. So, it means the quotient either clockwise or counterclockwise. So, for example, tan. So, for tangent, we have sine over cos. So, let's check if it is correct. So, here. So, we have tan x is equal to sine x over cos x. So, for sine x, we have sine x. So, we have cos over cot, and so on. So we have cos x is equal to cotangent x over cosecant x. Then cotangent x is equal to cosecant x over secant x. Then cosecant x is equal to secant x over tangent x. Then the secant x is equal to tangent x over sine x. Then for counterclockwise, we have cos x is equal to sine x over tangent x. Then sine x is equal to tan x over secant x. Then tan x is equal to secant x over cosecant x. Then secant x is equal to cosecant x over cotangent x. Then cosecant x is equal to cotangent x over cosine. Then cot x is equal to cosine x over sine x. So for product identities, for the product identities, a function between any two functions is equal to those two functions being multiplied. For two functions opposite each other, their product is equal to 1. So we have sine x times cosecant x is equal to 1. So, if we multiply the opposite, the sine to its opposite, which is cosine, the result is 1. If we multiply cos to secant, it equals also to 1. And also tan to times cotangent is equal to 1. Then, if we multiply the two between the two functions is equal to those two functions being multiplied. So, for example, we have tan x times cosine x. So, we have here tan x multiplied to cosine. So, if we multiply tan to cosine, the result is secant. So, if we multiply tan to cos, the result is sine. And if we multiply the cos to cosecant, the result is cotangent. So, that is the product identity. Then, let's proceed to reciprocal identities. So, all of the reciprocal identities can be found by going through the one. So, sine x, we already know that the reciprocal of sine x is 1 over cosecant. And because x is equal to 1 over secant x, then tangent x is equal to 1 over cotangent x. Then cosecant x is equal to 1 over sine x, then secant x is equal to 1 over cosine x, then cotangent x is equal to 1 over tangent x. So Pythagorean identities, going clockwise or counterclockwise around the three inside triangles started at the top and using addition. Going clockwise or counterclockwise around the three inside triangles starting at the bottom and using subtraction. So we have the example. So prove that cosecant squared theta is minus cotangent squared theta divided by cos theta is equal to secant theta. So first, we're going to use Pythagorean identity to get 1 over cos theta. So the second, the reciprocal or the Pythagorean identity of this is 1 over cos. So in Pythagorean identity, the cosecant squared theta minus cotangent squared theta is equal to 1. So we have 1 over, copy the denominator which is the cosecant theta, then equal to secant theta. So 1 over cos theta is equal to sec theta, which is by basing the reciprocal identity. So it is proven that the cosecant squared theta minus cotangent squared theta over cos theta is equal to secant theta. So let's proceed to number 2. Prove that sine to the power of 4 sine raised to 4 beta plus cos squared beta times sine squared beta is equal to sine squared beta. So let's factor first. So we have sine squared beta times sine squared beta is the factor of sine raised to 4 beta. Then plus cos squared beta is equal to sine squared beta. So we will use Pythagorean identity to get 1. So copy the sine squared beta, then the sine squared beta plus cos squared beta is equal to 1. So copy the sine squared beta in the right side. So after that, we will use multiplicative inverse to get sine squared beta. So multiply sine squared beta times 1 is equal to sine squared beta. So it is proven that the sine raised to 4 beta plus cos squared beta times sine squared beta is equal to sine squared beta.